This video is intended to provide an example of a slightly more advanced simulation model that can be built inside Arena. Now, this model is highly motivated by thinking about an airport security modeling problem. In Arena, if you go into Arena and say you can go to the file and then browse examples, you'll find that there are several airport security example problems that have already been pre-built by Rockwell Automation. The simplest case here, airport security example, if I were to open that up, is a nicely formatted case here where it simply has arrivals to a document checker. Passengers arrive, they get checked for proper identification, and they either pass security or are declined. And then they've adjusted the 2D animation down here so that passengers that queue up waiting show up down here. And so there is an animation for the document checker, which represents whether they're idle or busy, and then the queue that corresponds to this process down here has been dragged down to here to give a nice 2D animation of the process. In order to show off the 3D animation features of the program, Rockwell has also gone and packaged with the software, if I go to Browse Examples, another airport example that actually makes use of the Visual Designer. In the Visual Designer, if I open this up, it'll look like the same program, and in some ways it is, but under the tools, I can go under Arena Visual Designer, and when I open that up, I get access to the 3D facilities in Arena that can be linked to the normal Arena models. So if I go to these 3D facilities here, once it renders, I will see a rendering of a three-dimensional document checker and passengers who arrive. I can even say that I want to enable Arena animation under the Run menu here. And if I were to hit Go in this animation, it's going to take a second to start up. I will soon see the 3D animation reproduce some of the visualization that we saw in 2D. So in a second here, we should see that passengers will line up along this line, and they will start being serviced by this document checker. See, there's the document checker being idle, the document checker is checking out this passenger, and new passengers arrive. So we can see the document checker as he decides to either let people pass or decline them. And if I go back into Arena, I can see a mirror of what's going on in the 3D world going on in the 2D world here. So those are just two examples that Rockwell Automation has used, motivated by an airport security case. The example we're going to work with is going to look a little bit more like this example extension 2, where if we open their example extension 2 here, we can see that they have built up from their document checker here, and now included an X-ray baggage check, and they have a counter that counts, I think, to 15, and when it reaches 15, select someone for additional screening. And then once they go through the additional screening, then they get cleared. Otherwise, if they were not selected for additional screening, they get cleared immediately, assuming that they did not fail security here. So we're going to build a model that's kind of motivated by this type of process flow, but we're going to add a little bit more of a loop to it and maybe have a little less visualization. So if we go back, this is what we're going to be building up in this video. We have arrivals at security. I am going to not worry about the document checker for this particular case. So they just so this may as well be the entering a government building where you have to go through a metal detector before you can enter the building. So they enter the metal detector. They go through the metal detector. They receive potentially they get selected by whatever the metal detector detects to receive extra screening. So they go through an extra screening process, get looped around, go back through the metal detector. Eventually, they will fall out, not be selected for extra screening, and be able to enter to the gates. And I've split these things up in these different ways in order for me to record different aspects out to an Excel spreadsheet afterwards, as well as to create logic, which is conditioned upon the history of the entities as they loop over and over through this system. So let's try to build this from scratch and see what we get. So I've created a new file, new blank canvas here. I'm going to go into the basic process, which is up here. If I drag a create on, I'm also going to drag this dispose here, and I'm just going to delete this line in between, and once I do that, I can zoom. So I'm going to press the asterisk key in a second here, and that helps zoom in so that I can just see what's the span of things on the screen. Okay. So this create process, we can call this passengers arrive, and I would assume that I have some data which allows me to model the time in between arrivals, which would be the reciprocal of the arrival rate if they were exponentially distributed arrivals. And so I am going to just assume that on average I get 1 passenger per minute, and not worry about justification for that. And then this dispose is when they actually go, passengers go to gate. And maybe modeling the other one, I'll end up putting that down here. All right, so normally when we have passengers arrive, we need them to go directly into the metal detector. And so I would normally create a process that I could drill down into that would represent the entire metal detector. And so I would make this a seize, delay, release, and I would add a resource that I would call metal detector. And so an entity would seize 1 unit of this resource. And if I only have 1 metal detector, that means they seize the entire metal detector. So that metal detector is tied up, so no one else can use it until this person leaves the metal detector. Now normally I would make this, like I said, a seize, delay, release. And so this 1 block would represent the passenger entering the metal detector and leaving the metal detector, and all the other passengers waiting for that passenger to leave the metal detector so that they can enter. But in this particular model, I would like to measure the time from when the passenger actually reaches the metal detector to when they leave the security system. So I don't care about how long they're waiting to get into the metal detector, but I do care about once they enter the metal detector, how long is it until they can finally leave. And so I'm going to break this up slightly, so that instead of being a seize, delay, release, I'm just going to make this first one a seize delay, and the delay is going to be non-existent. So I'm effectively just doing a seize. Now, the more advanced students may know that in the advanced process panels, you can actually just get a pure seize. But I'm going to try to stick to the basic processes as much as I can. I am going to have to, for the file writing and reading, I will have to violate this a little bit, but most of the logic here I'm going to try to build with the basic process elements. And so I'm just making this a seize delay with a constant 0 delay. I'll make it 0 minutes, but it doesn't really matter. Now because I've seized it, it creates a queue over top of here. So I'm going to call this enter metal detector as the process here. And this means that entities can enter the metal detector, but so long as the metal detector is busy, the entities queue up on top here. So I need another process that will eventually represent the time it takes for them to move through the metal detector. But before I do that, I'm going to create an assign block which saves the time that the entity actually did entering the metal detector. So I am going to say, save I'll say detector entry time, and I'm going to say this assigns an attribute called detector time, and I would normally just say tNow, which is Arena's way of saying the current time. If you ever forget these, you can always right-click on these expressions, go to build expression, and then try to find them. So date and time functions are down here. Current simulation time is here. When I click on that, it fills in tNow. So I normally just do T now, but I know that I am going to cause these agents to cycle back around through the metal detector multiple times, and I only want this attribute to be updated once. So there are a lot of different ways of dealing with this. I'm going to use a little bit of a hack here. So what I'm going to do is I am going to put at the front of this, if I go to build expression, and T now is there, if I go to math functions, I can take minimum value, and I'm going to make T now in 1, and then detector time, the second value here. And by doing that, as long as I initialize detector time to be a very large number, then this attribute will only get set the first time an entity goes through the metal detector. All other times through the metal detector, it'll get saved at its previous value. And that allows me to save the total time the entity is in the system once they reach the metal detector. Again, there's multiple ways I could do this. This is just one sort of simple way that requires less elements and less if statements and complex expressions. It does require me to do something, though. I now have to go to the attribute data module over here, and for detector time, I need to make sure that the initial value, which I'll edit via dialog, I need to make sure the initial value is very large. Okay, so passengers are created. They have a very large detector time. They wait to enter the metal detector. The instant they enter the metal detector, they exit this block. They save the detector time, and now it's time for them to actually go into the metal detector. So I bring another process out, and in this process, I can call this pass through metal detector, and I can make this a delay release, where its resource is the metal detector resource that I've just created in the previous one here. And I don't know how long it takes to get through the metal detector. I am going to model it without any data here as an exponential with mean of 4 seconds. So I'm going to say expo 4. And that's added to the value added timer here, or allocation here. Okay. So now I need to figure out, based after when they've gone through the metal detector, some of them are going to be selected for extra screening based on the metal detector results, and some of them aren't. So I'm going to create a two-way by chance, and I will say that, say, 20% get selected for extra screening. The other 80% can go on. So I'll say selected for extra screening. Okay. The extra screening process is another process, which I can put down here. So if they get selected for extra screening, they go through the process here. And this process I can call extra screening. I can make that as well a seize delay release. This one will seize a resource that I will call security agent. And I don't know how long it takes to do the extra screening, but I'm going to assume it's somewhere between 30 seconds and 75 seconds with an average of 45 seconds. Or a mode of 45 seconds. And I'll use a triangular distribution for now. If I had real data, I could probably put that in there, but for now, that's all I'm going to do. All right. Now, what I'd like to do is then assign another attribute, and I will call this one Numb Screening. And I will just assign it to Numb Screening plus 1. In other words, this attribute represents how many times this entity has gone through extra screening. So if I want to be formal, and I go down to the attributes list here, Numb Screening, which now shows up, I can make sure, if I do edit, I'll do edit via dialog, I can make sure that it has an initial value of 0. So entities come in, their number of screening is 0. If they're selected for extra screening, it'll get incremented to 1. And then they go back through the metal detector. So I'm just going to grab the wiring tool and just go over the top here. So now everyone goes through extra screening. Now that I actually have a count of how many times I've gone through extra screening, I'm going to revisit this selected for extra screening box. Right now, the %true is set to 20%. 20% gets selected for extra screening. But if extra screening actually works, then the second time people go through extra screening, one would think that they would have be less likely to be selected for extra screening because it'd be more likely that the security agent found whatever the problem was that caused them to be flagged by the metal detector. So we would like this to decrease along with the extra screening. So what I'm going to do is I'm going to change this from a two-way by chance to a two-way by condition. And I'm going to make the condition an expression. And in that expression, I'm going to use something called unif01, which is a uniformly distributed random variable between 0 and 1. And this random number between 0 and 1 has the nice property that if you compare it to some expression, then if that expression gives you a number between 0 and 1, then this statement will be true with a fraction that agrees with this expression. So if I were to put 0.2 here, then I would have reproduced what was already there when I had it as a two-way by chance. This will be true 20% of the time. Now what I want to do is make it 20% only for the first time. So I can create a little expression like this one. I can say, well, what if I do 1 divided by Numb Screening plus 1, where Numb Screening plus 1 is all in parentheses in the denominator of this fraction. If I do that, then when Numb Screening is equal to 0, as it is initially, then there will be a 20% chance of being selected for extra screening. But the second time around, Numb Screening will be equal to 1, and so this scalar on the 20% will now be equal to a half, which means the total percent here that this will come up true is now only 10%. Then if that person is unlucky enough to get selected for screening again, then this Numb Screening will be equal to 2, which means that 20% will be divided by 3, and so on. So this allows for the selection for extra screening to decay towards 0 as the number of extra screening goes to infinity. Okay, now I'm almost done. I would normally just route this selected for extra screening false directly to passengers go to gate. But I am going to dial into the advanced processes now and grab this read-write block. And then I'm going to wire up the false branch here to the read-write block, and then the read-write block to the dispose. Inside the read-write block, I am now going to save data. Now, there are a number of different ways you can save data out of an arena simulation. For one, after you run any successful arena simulation, it'll ask you if you want to look at a report, and that report will give you a lot of summary statistics and confidence intervals about various pieces of data that are important to the simulation. Another option is to use the statistic data module over here in Advanced Processes. If you were to use this statistic, you could actually grab a wide variety of data from a particular simulation and open it in the Output Analyzer. The Output Analyzer is not accessible from directly within Arena, but in Windows, if you go to the Rockwell Automation folder that holds Arena, you can find the Output Processor. The output processor opens these special files that are written by the statistic file and allows you to analyze them, particularly perhaps with statistically rigorous tools in order to compare, for example, how outputs from different replications differ, or outputs from how different models might differ, or even when you're doing validation, it could compare how well real data compares to data from the simulation. There's a bunch of resources on how to use the output processor, but I know a lot of people just want to use R or Excel or MATLAB and would like to get just raw data out. There are ways in which you can tell the output processor to then convert some of the data that it gets from these models into models that you could import into those tools. But you can also have Arena write directly out to a spreadsheet that you can open in Excel. And that's what we'll experiment with here. So in this read-write block, I'm just going to rename this, call this write out entity times. And this here is going to be a write to CSV output file, comma separated values. And the file name, I'm going to have to deal with that separately, but for now, I'm just going to put in an identifier, and I will call it, my output file. And this is not actually the file name, this is just a handle that's used inside Arena. In a separate spot that we're about to get to, we actually define the file name. The assignments are each column that will be written out when a single row is written out when an entity passes through this module. So the first column I might want to write out is I'm going to go to Other, and then under Other, I can then build expression, and I would like to write out the replication number. So under replication variables, current replication number, I get nrep, and I'm okay with a format integer. If I run multiple replications of this simulation, I want to be able to make it clear where the data from the first replication stops and the data from the second replication begins, and this lets me do that. All right. Now, I might also want to write out whether this entity received extra screening. So I can write out an attribute, and I can write out Numb Screening. And this also can be an integer. And then that means that in that column of this row, I get to see how many times this entity went through extra screening. What else do I like to write out? I might be interested in, for example, how much time the entity spent just in service activities, where service activities are passing through the metal detector and going through the extra screening, not including the time waiting for the extra screening. Excuse me. And so in this case, that will be referred to as the value added time. So I'm going to go to Other, and then I also will go to Expression Builder, and I can then say this is an entity related variable, it's an attribute, it's a time, and there it is, entity total VA time, otherwise known as entity.va time, value added time. And now I need to make that a real number. Finally, in the fourth column, I'm going to do something similar. I can do Other, but now this expression, and I'm going to make this a real, now this expression I want to be the time since the passenger actually entered the metal detector, not including the time waiting before the metal detector. Well, that's just going to be tnow minus detector time. Where detector time was written to back here, tnow is the current time as the entity is about to exit the simulation. All right, so I have my 4 columns. Now I just need to properly open the file. So in the Advanced Process panel, there is a file, and it's already pre-populated with my output file. I'm going to edit this as a dialog to make it easier to read. And I'm going to make this a CSV file, CSV output file. I'm going to choose a place to put it. So I'm just going to put it somewhere on my desktop in this desktop test folder, and I will call this passenger time output, then it should automatically add a what I'll do.csv. Now here, these are the CSV column headers. These are optional, but they're good to put in there so you remember which is which. Just so you know, though, that if you change things in what you're writing, you need to remember to come back and change them here so that the orders always match up. So the header text for the first one is I want replication to be the first header. And then I want Numb Screening to be the second. For the third, I want Detector time. And for the fourth, I'll put passage time. Okay. And so now I'm going to go to Run Setup, and I am going to run this for each replication for 1 day, and I'll make each day 9 hours long. And I might run 5 replications. Okay. I guess I'll make my base time unit minutes. Okay. Now, just while the simulation's running, I might want something to make it more easier for me to tell how far along it is in each replication. Now, when you run down here in the status bar, it actually shows you the current time and the current replication. But I'm still going to go on here and click on the clock here. That's this funny little thing. Clock. And I'm going to start a clock at 0. It will be a digital clock. It will be a 24-hour clock, so that 0 means 0. And I don't care about this other stuff, but I guess I could do transparent background. And I might as well put that here. All right. I think I've handled everything. Never quite sure. So I'm going to hit run and see what happens. Looks like I have an error. All right. So it looks like I misspelled detector time. So go through here, change this to detector time. Now let's see what happens. All right, looks like it's working. Now, if I pause, I don't really catch any in the act here, but it's kind of disappointing that the people look like little stacks of documents. So I'm going to go back to the basic process panel. And under entity, then I'm going to change the picture to picture.person. And for now, I'm going to leave the entity type just as entity1, but I could have renamed that like person or something. And then while I'm thinking about it, I'm also going to go to the queues here, and I see I have 2 queues, and they're both set as first in, first out. Now, those that go back through screening, in this loop here, they probably should go to the head of the line. So what I'm going to do is change the first in, first out to highest attribute value on both of these. And the attribute I select will be the Numb Screening. Down here, Numb Screening, which is at the bottom of this list. Because I know that thing increases, so as you get more and more screening, you get prioritized more and more. All right, now let's play. And I might slow the simulation down with this slider just so I can watch what's happening. I see little people arriving, getting routed in different ways. So I can speed this up, or I can fast forward. And down here I can see it's on replication 1, and here's how many minutes it's gone through. In a second here, now it's on replication 2. And so this will keep going until we get through replication 5. And then we'll see what we can get out from this. So in a second here, it's going to ask me if I want to see my results. I'm going to say no, because I am going to focus in this video on using Excel to look at the sort of more raw data. So I said no to that. And now, if I move Arena out of the way, and the Visual Designer from before is still up, so I'm going to close it. Then hopefully I have a new file in that folder called passengertimeoutput.csv. Because I created it as a .csv, if I double click on it, it should open in a spreadsheet program. In my case, the default program is Microsoft Excel. So that's what we have here. And as I expected, I have 4 columns. And those 4 columns are replication, Numb Screening, Detector time, passage time. If I look through here, several people got selected for screening once. And here's at least one person that got selected for screening twice. Now, I see the 3rd column here is detector time. The 4th column is passage time. Now, in principle, passage time should always be greater than or equal to detector time, because it is taking the time since the beginning of the simulation all the way to the time at the end of the simulation. So if I go and hit stop here, and I look at these write out entity times, time t now minus detector time should always be greater than the value added time, because this interval should always include all of the value added times as well. What's alarming to me from a verification point of view is that there are cases here, like that case that I was just looking at. I think I saw a case up front here too, like this one, where entities are selected for screening, but their passage time is smaller than their detector time. That makes me worry that perhaps this saving of their time has got the wrong thing in it, and it looks like it does. I meant for this to say minimum, but I must have clicked on maximum. So I will go back and click Build Expression, and then I will go to Math Functions, click Minimum Value, and now it says MN. So rather than me having it obliterate everything, I'm just going to type MN, because now I know that is what Arena uses. All right, so now I have more confidence that when I run this, the output should make sense. So I'm going to run this again. I will fast forward so that it finishes faster. While I'm doing that, I can go back to the Excel file and just point out that even though this column is wrong, we can still see the basic principle that a lot of entities from replication 1 occurred, and then suddenly, around after the 532nd entity, replication 2 starts. And that keeps going. And overall, I have 5 different replications worth of data, which you can kind of think like me simulating 5 days of the week, Monday, Tuesday, Wednesday, Thursday, and Friday, where everything shuts down between days and starts back up on a virtually identical day. All right, simulation finished. I don't want to see results. I will go back to Excel, and I'm going to close this Excel spreadsheet, which if you're on a Windows machine, I'm on a Mac, then you may have had to close that Excel spreadsheet before even running your Arena, because it keeps the file handle open. So now when I open through this, I should see that this entity that was selected for additional screening, now its passage time is strictly larger than its detector time. And whereas a bunch of the others here, the detector times and passage times might be similar. But now it looks like I have this strange property here that the passage time keeps getting longer and longer. So again, it looks like I've done something wrong. So I'm going to go back into here. I'm going to look at this save detector time, and it says that I'm assigning to the attribute detector time the min between now and detector time. That looks fine for me. I'm going to look at the attributes, and I see that, aha, that spelling error that I had before is plaguing me now because the actual detector time should be spelled detector time. So I'm going to delete the extra row here and make sure I only have an attribute spelled correctly. I'm going to edit that row via dialog. Make sure the initial value is very, very large. Save this file. Well, I would initially save this file, but then I'm going to run it again. So now I'm pretty confident I fixed all the bugs, but we'll see. That's why looking at the data, a big part of looking at the data initially, is the verification step. Do these data make sense based on what I expected, based on what I wrote in the code? If they don't, then that tells me that I need to go back and check my code because I might have made a mistake. And that's the process of verification. Comparing your output to the real system, that's the process of validation, which we're not doing in this video, but we apparently have had plenty of practice with verification. So hopefully we're done with verification. Let's go to passenger time output again. And this is starting to look a lot better because I see that most of the time the detector times and the passage times are identical, which is what you'd expect if no one was selected for screening, because the passage time would include no delays because it starts right when they enter the metal detector. But when they're selected for extra screening, the passage time might become longer than the detector time because might become longer than the this value added time. So I probably should have titled this column value added time, not detector time, because an entity had to wait. So if I scroll down through here and I look for entities that were selected for extra screening, lo and behold, I do find one selected for extra screening that apparently had to wait in a queue on its second time around. And that's why its passage time is greater than this poorly named column detector time, which really should have been like value added time. All right, so what do we do with this now? Well, I might be interested in seeing what the distribution of passage times looks like. So I am going to highlight, this is in Excel, I am going to highlight everything in the first replication only for now. So I'll go down to where I go from replication 1 to replication 2, and I'm going to go to Insert, and then I hit this here, which are the statistical options, and then go to histogram. And on a Mac, it's slightly different than on a Windows machine, but on both, you should be able to generate a histogram in roughly the same way. But if you might want to go into this histogram and say right-click on this and do Format Data Series, on both the Mac and a Windows machine, you should be able to play with things like the bin width and such of the histogram, but they might be located in different locations. You could have also brought this into R, done a histogram, brought this into MATLAB, and done a histogram, and so on. I'm just sort of bringing it into Excel as the kind of lowest common denominator. Excel sets the bin width to auto. I'm just to seeing how things look at a higher resolution. I could set the bin width to 0.1 instead of 0.21, or maybe even 0.05. And I start seeing a little bit more structure here. Now, this is an interesting distribution. It's very high here, and then it kind of is a lump here, and a kind of a long tail. So it has a lot of representation still out here. Does this make sense to us? I think it does. I think what you're seeing here is that these are the bulk of passengers that were not selected. Those that were selected have to not only pay the cost of their original passage time through the metal detector, but an additional screening cost, and then on top of that, another metal detector run. And that means that they show up here in this second mode. The very few numbers of them who are then selected again will end up showing up out here. So if I were to always have, say, a fixed probability of being selected for screening, extra screening, even if you've already been screened before, then we might expect to see lots of these peaks. That they would still decay kind of exponentially, but they would be much more pronounced here, 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 and so on. So this is a pretty interesting pattern, and I like showing this pattern because the input models that we put into here ended up being a triangular distribution as well as an exponential distribution, but we get out of it this sort of service time distribution. If you think of the time into the metal detector and the time out to the gates as one long service, that has this very different shape, which if we tried to model this alone as a single service and not this broken up iterative process, it would have been very difficult to fit this model. Now, the last thing I might want to do is I could generate histograms for every replication, but just to test my theory, I might go back into here, and under the selected for extra screening, I might make it much more likely that the individuals are selected for extra screening. So instead of starting at 20%, why don't we just start it at 80% and let this model run and see how it changes the histogram in Excel. If we're understanding the process right, then after I do that, then I should see a bunch of sort of a multimodal plot of times that go from when the passenger entered the metal detector to when they finally exit and go out to the gates. And it's about to finish, the last replication here. It's taking a little longer, I think, because more passengers are being routed back through the metal detector. All right, so we'll go back into Excel. Let's look at this passenger time output, specifically column 4. I'm going to highlight, let's say, just the replication 1 data, although, again, it's good to sort of check across replications. Insert, statistical, histogram, and I get something that's definitely more spread out, but I want to see how much of that is an artifact of the bins. So I'm going to do format data series, bin width, and the default bin width is 4.5. What happens if I change it to 1? Okay, what happens if I change it to 0.25? All right, so maybe 0.5. Okay, so things are much, much noisier, but I do see that I get much more representation. It doesn't just kind of simply die off. And I might try selecting just the value added time rather than all of the queuing time and see what that might look like as a histogram. So let's try that. Insert histogram. And again, let's see what happens when we play with the binning here. Format data series, bin width, say 0.1. And now things are starting to look more like kind of expected. So we have this initial exponential. You can see a strong triangle, another triangle, another triangle, and so on. So basically, if I look at just the value added time, which is just the metal detector time and the extra screening time without any of the lining up, then I get the kind of multimodal distribution that I might have expected. If I then add in the extra time that these passengers are waiting in the queues for extra screening, and maybe even the queues for going back through the metal detector, then I get that second histogram, which I think is probably loaded way down here, where things are much more smoothed out. All right, so that's the end of this relatively more complicated example. I am going to follow up with one other video that shows us how to change capacities and arrival rates in a scheduled manner inside of Arena. So stay tuned for that.